We are back online. Okay, so we are going to build this kind of dynamic musical instrument here. And so let's figure out how to do this. So I'm going to start fresh here. I'm going to delete everything in the space here. And I'm going to actually just do file new in this case. Okay, so the first thing we need to do is we're going to start by creating our pad. This is a thing that we're going to strike to cause something to happen and on collision. So this is going to represent kind of our musical, our key, basically, our musical key that we're going to strike to produce a sound. And so I'm just drew a simple box here. And so basically what we want to do is when something strikes this, we want a sound to play. But before we can do that, we have to kind of figure out, okay, how do we detect that a collision has occurred? And so to do that, we're going to be using something called the collision model, and we can find that by right-clicking in the browser and going to collision models and creating a new collision model. Now you can think of a collision model as a material, basically, similar to like if I create a new material here and I drag and drop this onto this object. It's assigning essentially a different material to the object. And the material in this case is the visual kind of way of rendering this object. Collision models in the same way are the collision kind of material. It's the collision properties of an object. And so we can assign that just like materials by dragging and dropping it onto a physical object. And what happens when we're dragging and dropping it is it's actually just going in here and assigning this collision model property of the object's rigid body to whatever we drag and dropped it to. So as you can see now it's set it to this collision model. So basically what's happening now is that this object now contains this collision model, which in this collision model, we'll be able to set up all of our logic to kind of trigger a sound to occur, or whatever else we might want. So back here in the collision model properties, we can see here that the first thing it wants in this little list here to the left is it wants a collision detector, which we can now add by hitting this little plus button. We select collision detectors and then hit plus. And with this, what we're now choosing is what type of collision do we want to detect? Do we want to detect an impact? Do we want to detect when the object is rolling, like for spheres when they're rolling? Or do we want to detect when it's sliding? Like in this case, if we were to throw this box on the ground, it would slide across the ground. And we can detect for that using using this collision detector. But in this case, we care when something impacts it, when something strikes it. And so I'm going to create a new impact collision detector. And so when we do that, the next thing we're going to want to do is under impact collision detector, which was just added, we want to set a collision response. So it's basically saying I've detected a collision, in this case an impact. Now we want to respond somehow, and we need to create a response. And so I click on collision responses, and I'm just going to click on a new script collision response. So that's basically saying when there's a collision, we want some script to call. And then once we're in script land, we can kind of have it do just about anything we want. And to write the actual code for to actually write the collision response, the script collision response, we're going to see when we click on script collision response on the right-hand side, we're going to see all the different events that are going to get called based on the different cases when something collides with it, and so forth. So in this case, the three we're interested in, or actually the one we're interested in, is on begin tracking, but I'll explain all three of them. So on begin tracking is called when the initial collision occurs. So think of a spear jabbing something. When the spear first jabs it, on begin tracking will get called. While it's jabbing it, i.e. it's like it's penetrating the surface, it's going to keep calling on tracking every frame. And then when the spear comes out of the surface, on end tracking would get called. So that's useful if you need to continually detect when something is puncturing something, etc. But in this case, we just care about when we initially strike it. So we're going to implement this on begin tracking event, which will get called just when it initially gets hit by something. So now, inside the script here, we can now detect all the different aspects we're going to need to understand what happens in a collision. And all the information that we care about is stored in this collision info object. And in fact, we can kind of go and find out more information about this by just clicking on begin tracking here and then hitting F1. And when we do that, a reference appears with all of the documentation that we care about regarding this function, this on begin tracking function. And in this case, we care about this collision info object, which is this variable that's passed into this function. And by clicking on this collision info, we can see all of the details of a collision. So think about this as kind of your snapshot of a collision. And in this snapshot, we have all this information. So we have things like the two bodies involved in the collision, because every collision occurs between two objects, so we can kind of figure out what those two objects are, and a bunch of other stuff like where on the object the collision occurred, what's the normal of the surface where the collision occurred, and a bunch of other stuff. And we'll get into a couple of these things in this lesson today. But the big thing we care about is what are the two objects involved in the collision. So just to kind of demonstrate the objects in this case, I'm going to actually store in two variables the two objects here. So I'm going to say collision info.body A. So that's this object here, and so body A returns the rigid body A of the two colliding objects. So the rigid body in this case of this box here is this object here. So it's literally going to return this object here in that variable. But we actually don't want the object. We don't want the rigid body. We want its parent. We want the actual parent object, the box entity. We don't want its attribute. We want its parent. So I'm just going to say body A : get parent. So now node A will contain this object here, box entity here. And then node B would contain whatever it's colliding with. So I'm going to say node B is equal to body B get parent. And so that would be whatever it collides with, which in this case the box is actually sitting on the ground, so we'll get the ground. And in fact, let's go ahead and print out their names so we can see exactly the two objects involved. I'm going to say print get name, and then I'm going to say print node B get name. So let's see what happens when I hit play. I'm going to pick up and drop this on the ground, and you can see when there's a collision, and there's a bunch that happen at once because I'm kind of like dragging it on the ground. But you can see here the two objects involved in the collision, the box entity, which is the object here, and then the ground in this case. So that's great. So that's what we care about. So now we've detected the collision, and we know the two objects involved in the collision. We actually only care about one of those two objects. We don't care about both of them. We just care about when the collision occurs, and in this case we care about when the first object, the node A, the box itself, when something collides with it, basically is what we care about. So this next bit is this is the little trick that we're going to do here. So what we could do right now is we could write all of our code in here to play a sound, for instance. So if we could go and find the sound in the space and then play it and place it kind of near the location of the collision. But I'm actually going to show you a nice little trick here to kind of organize our code in such a way that we can then forget about the script collision response and actually go and write all the code to play the sound and stuff in the object itself. Because right now we're inside this script collision response, this material, so to speak, of the collision, and we really want to dispatch out of this thing. We want to, like, okay, now that we've detected it, let's go and actually just go and call some code on the object itself, so then we can kind of work locally on the object. It's a much cleaner way to do this. And so I'm gonna write the code now, and then I'll kind of I'll dissect it after it's done here. But basically, what we're doing is we're saying, okay, let's go ahead and look on that object on node A to see if it has a function called onCollide, and if it does, we're going to call that function. And this will make more sense in a bit when we actually go and implement that onCollide function. And I'm going to do the same thing for node B as well. So basically, when a collision occurs, we're going to go and hunt for a function that lives on node A, which we're going to be adding in a second, called onCollide. And if it finds that function, it's going to call it. Now, the reason why it's useful to do this little if statement, this trick is actually really, really useful. It allows us to make more robust objects. So in other words, if I have an object that I apply this collision response to, but I'm lazy and I don't implement this onCollide function, this will basically filter out. It won't throw an error. If it tries to call a function that doesn't exist, it will throw an error and it will stop our show. So this little trick here basically says, does it have a function called onCollide? And only if it does, do we call it. And this is actually what's referred to in a more general way as a virtual function. It's basically, it virtually calls it. If it happens to have it, it will call it. If it doesn't, it doesn't. You can think of this as a virtual function. And so we do this for both node A and node B, so that if we have two objects involved in a collision, this script collision response will kind of call the onCollide function on both of those objects. Okay, so this is all we care about in this script collision response. We can now safely close this, and because we're done with it. So now what we have to just do is we have to just go and write this onCollide function, which lives on the object itself. And so to do this, I'm just going to click on the box entity, and then I'm just going to, you can see all the events that you can implement here. If like onTick, this gets called every frame, on move when it gets moved. I'm just going to click on onInit. We're actually not going to implement the onInit function, but it's just a shortcut to kind of open our scripting window for this object. And then I'm going to implement meshEntity.onCollide. So this is the function that now is going to get called when a collision occurs. And actually, I'm going to just print a statement here so we can see it actually working. So now what's going to happen is whenever this thing experiences a collision, that script collision response, that material we applied onto this object, that collision material, collision model, it goes into this object and calls this onCollide function, which so now we're inside the object itself, and it's much easier for us to now organize our state around this. Okay, so now this is the right place for us to do something interesting when a collision occurs. And so what we want to do is actually we want to play a sound. So when something collides, when something hits this box, we want it to play a sound. So the first thing I'm going to do is I'm just going to import a sound. And to do that, I'm just going to right-click anywhere inside the browser here, and I'm just going to say import audio clip from file. And I just happened to download a few audio clips from freesound.org. You can pretty much use whatever sounds you want, obviously, wherever you happen to want to find them. I just like freesound.org because they have a lot of sounds that are you just have to give attribution to the original artist to use them, and so in this case I'll use this ktom verb from this user called Noise Collector on freesound.org. So you can go and find this user and find this sound if you're interested in it. So I just double click on that, and that imports our audio clip. And now I'm just going to drag and drop this into the space to actually create the sound on our object. And then the other thing I'm going to do is I'm going to click on this. So let me explain a little bit about what these two different objects are. So in this case, this is just your data, your audio data. It doesn't play or do anything. It just kind of lives inside your library. Think of it as like a resource. It contains the actual audio data. Then when I drag and drop it into the space, it's creating a sound in the space. This is like basically saying, okay, I want that sound to play from this particular location in space. And so this is actually what we're interested in to call play on. So I'm going to go ahead and rename this sound object. So I just click on it, and I'm just going to give it a name of sound here, so it's a little bit easier for us to find it later. So I called it sound. And the other thing I want to do is I want to make it a child of this box entity. So right now they're not children, they're kind of siblings right now of one another. So one thing does not control the other thing. And so I want to make it a child of it, so it kind of is structured underneath the box. So now the box, it moves with the box basically. And we also want to do this because we're now going to search ourselves for the sound. So remember that right now we're inside the box's script, and we're implementing this onCollide function. So now what I want to do is I want to find the sound that lives on myself. I'm going to say sound is equal to self:"find node by name," and I'm just going to search for this sound object, which it matches the name we just gave it. So you can call this whatever you want. You just need to make sure that this matches that name that we gave it in this case. So, and I'm just storing in a variable called sound. That could be whatever we want. I could just say SMD, like a shortcut for sound. We can call this whatever we want. So this is basically saying search myself, this mesh entity, for a child that has the name sound, which is this object we've added, and we're going to store that in sound. So now we can say sound:"play, and it will play the sound. So now when something collides with this, it will play this sound. So let's see it actually work here. So I'm going to create another sphere here that we can just drop on it. And there you go. I'm going to aim a little bit better here. So every single time it gets hit, it plays that sound. Okay, so we're getting kind of close to what we want here. One other thing I might do here is I might make this not movable, because right now it's movable, so it also will collide with things. And I'll show you also how to set the sensitivity of the collision. Right now, you need to hit it with a fair amount of force in order for it to generate the collision event, and we can make that more sensitive. But what I'm going to do right now is I'm going to just click on this box, and I'm going to set its rigid body property to false, movable to false, which will mean that it doesn't move anymore. So it makes it nice and stable, so we can now hit it, and it doesn't get displaced by the sphere. Now, another thing you might notice is that with this sound, it's a little harder to tell, but it actually, because we are calling play on the sound, it essentially rewinds the sound. If we hit it too fast, it's not like each sound is playing and then we hit it again and it plays another sound additively on the original sound. No, actually what it's doing is it's essentially only allowing us to play it exactly once, and it's cutting out the current sound. If it was playing, it would cut it out, it would shorten it and then reset it to the beginning, which we don't want. We want it to be kind of additive. So if we hit it a lot of times, we get this nice additive effect. So instead of calling play on the actual sound object, we're going to play a shared copy. That means it's going to make a copy and play that. So it means every time it gets hit, it'll play another copy and another copy and another copy. And so by doing so, we have an additive effect. So each copy adds itself to any previously playing copy. So it's a much more realistic kind of way of playing a sound. And so when we call play shared copy, it's actually going to return our sound in the form of a variable. This is our sound copy. We can think of this as our sound copy. And the other thing we're going to want to do is, because it's going to place all these copies in the space, it's going to leave all these things in the space. So we want to do a little bit of garbage collection to make sure that these things are removed after they're done playing. And so to do this, I'm just going to do this little trick here. I'm just going to call on our copy. I'm going to do fade out and orphan. So this is going to remove it after it's done playing. And I'm going to do it using our sounds audio clip. That's the actual sound that it's playing. Get time length. And I'll explain this a little bit better here. So the audio, so the sounds audio clip, if we go into the sound object and we take a look at its audio clip property, this is what we're essentially getting when we say sound.audio clip. We're getting this object here, which actually refers back to this object here, which we dragged and dropped. This is the same object. And we're getting its, in this case, we're calling a function on it that's saying, get me the length of that time, the length of the clip, however long it is. So in this case, the sound probably plays for like 2 seconds. It's going to return 2 seconds. And so what this is going to do is it's going to say fade out and orphan this thing, wait 2 seconds, and then it's going to fade it out. So the first argument of this is how long to wait before it gets faded out. And so we want it to wait exactly the length of the sound of the sound itself. So this is important, this little detail, just because it will remove all the copies, or else it's going to leave all these copies behind. That will play once, but then you'll have all this stuff remaining in the space, and we need to do a little bit of memory management, a little garbage collection to make sure that we don't get way too many objects in here. So let's go ahead and hit play and see how this works now. It'll sound pretty similar, but I can now hit it many, many, many times, and with a longer sound, we'll be able to hear this better, and I'll show you that later. And then after they're done playing, they're getting removed from the space using that fade out and orphan. Okay, so now that's nice and robust. So another thing we're going to want to do is let's also create a visual representation of it hitting it, so that we don't just hear it, but we'll also see it. And so to do this, we're going to make it glow, and I'm going to show you now another function, a global function to animate things. And in this case, we're going to say get animator, create key clip on our color property, and I'm going to dissect this now. So, and we're going to store this. The return of that is going to store in this variable called clip. And so what this function does is it allows us to animate any property of an object. So if we look at the properties of this box, for instance, it has this color property. And we basically want to animate this color property. We want it to, in this case, we want it to do this. We want it to kind of glow every single time it gets struck. And so what this is doing basically is saying get animator, which is this global function, create key clip, which is saying I want to create an animation clip using our color property. And how did I know about this? If we click on the mesh entity here and I hit F1, and I move my way up. So the mesh entity, this is the object that we just clicked on, the box, and this thing inherits all the properties from entity. So I moved up one level in this case, and you can see that there's this color property here. This correlates to our property here in the property editor. And if I click on it, you'll see that there's this function called get color property, which basically says this mesh entity has a function called get color property, which returns this object, this entire thing you can think of. It returns this that we can then use to animate this value. So anyways, that's long story short. This will allow us basically to animate the object's color property. If we wanted to animate its active property, we could say get active property instead. And in this case, we're going to say get color property. And so the next thing we want to do is on this object that's returned, we want to create, we want to add keyframes to it. And so to do that, I'm just going to call this add key function. And the first parameter wants to know how long to wait, what is the animation time basically to reach this keyframe, this first keyframe we're going to add, and then what is the keyframe value itself. So what we want to do is basically take our color and multiply it by 10. So it'll essentially make it 10 times as bright. Is basically the idea. Well, actually, it's going to increase its value by 10. It's like multiplying out its brightness value by 10 times. So that will kind of make it get very, very bright like this. And then what we want to do is we want to have it return to the original brightness. So we're going to say add key, and again, wait, and this is our next keyframe. We're going to go to 0.2 of a second, and we're going to say self.color. So basically what this is going to do is going to return us to our original color. So this says take our current color, multiply by 10 is what we're going to animate to, and then we're going to animate back to our current color, whatever that happens to be. So now if we hit play, you'll see that when it gets hit, it will now also glow. Now you're going to see another thing happening here. So this is a simple case here, so you can see it glows every time it hits. Now the problem is that if I hit it really fast, it will kind of keep getting bright and not return, and that's because we're actually hitting it before the animation completes. So then next time it collides, it's going to say, oh, my color is already brighter, so it's going to make it 10 times brighter than that, and then it gets kind of in this weird kind of state where it continually gets brighter and brighter. So we don't want that. So how do we fix this? We're just going to, before we do the animation, we just need to make sure that the last animation that happened maybe the last time we hit it is completed. And so to do that, we're just going to call stop animation. Oh, sorry, we're going to go get animator stop animation. And we're basically saying stop the, in this case, color animation that we happened to do last frame. And so that will stop that animation, allowing us to then create a fresh new animation with the values that we want to control. And the other thing you need to do here is say comma true. Because stop animation will simply stop the animation and whatever its value happens to be, but comma true will basically fast forward it to the end. So that means if we hit it twice really fast and it hasn't completed the animation from last time we hit it, this function will ensure that it forces it to the end value, which is basically what its original color was, before we queue up another animation. And so now if we hit play, you'll see that no matter how often we hit this, we can't get it to like do that bright saturation thing. Okay, so now we have a nice kind of repeating way of playing a sound every time this thing gets hit. Now one other fun thing we can do is, another thing we might want to do is vary the pitch of the sound based on how hard we're striking it. So the harder we hit it with the sphere, or maybe in VR we hit it with an object, we can make it so that it plays at different pitches, so that the pitch of the sound correlates with how hard we hit it. So to do this, we're going to have to transfer in to this onCollide function some additional details that happen when the collision occurs. And so to do that, we're going to go back to our collision model. I'm going to click on the original collision model that we created, where we created that dispatch code. And I'm going to go and find that script collision response and go back into where we originally wrote this function here, this collision response function. And this collision info object, if we hit F1 on begin tracking and we go and hunt that object down, it contains all sorts of other interesting other interesting variables. And the other interesting one that we care about is this applied impulse, which essentially represents the amount of impulse. You can think of the strength of the force that is injected into the objects to make them kind of collide and move in opposite directions. This value is going to be proportional to the strength of how hard we're hitting it. And so this is perfect. This is the exact value we're going to want. It's just a number. And so with this value, we're going to be able to use this variable to modulate the pitch of the sound as it plays. And so basically what we need to do is we need to carry that through into our onCollide function. So I'm going to just take the collision info and take the applied impulse, which is that variable impulse, which is this variable here, and I'm passing it straight through to our onCollide function. And I'm going to do that for this as well, for this node B1, so that both of them get called with that applied impulse. So now if we go back into the script on our original box here, where we were adding this sound, our onCollide function now will have an additional value passed in called the applied impulse. So I'm just going to write this variable here. And so now this will be whatever the strength of the strike is. And so I'm going to print that out. I'm going to print that variable out so we can kind of see it here. So every single time this gets struck, it's going to print out that value. So you can see as I hit it really hard, it's a large number. It's 8 in this case. If I hit it lightly, it's only 1. So that's perfect. That's what we want here. Now the harder we hit it, or the higher the velocity of the object that hits it, the higher that value, and so then maybe the higher the pitch will be of the sound, and then the slower we hit it, the lower the pitch is. And so to set the pitch in this case, we're going to take our sound copy, that's the thing that's returned when we play a copy, and we're going to set its transpose pitch property. So transpose pitch is equal to, and in this case we're going to just set it to the applied impulse. So we're literally just setting the transpose pitch directly to that force value. So it may or may not map well, and we can then we can massage the value mathematically a little bit to make it map a little bit better. But let's see what it sounds like when we hit play. So by the way, what we're programmatically setting is in the sound, you'll see that there's this transpose pitch value, and this is what we're essentially setting when we do that. We're setting this value here. So let's see what happens when we hit play on this. So now the harder I hit it, the higher pitched it is, and the slower I hit it, the lower the pitch is. But the problem is this is always a positive value applied impulse. And so our transpose pitch that we're setting the sound to, right now it's only setting the positive ranges of this transpose pitch value. So those are like higher and higher pitch sounds. We might want to go lower pitched as well, not just higher pitched. And so what we're basically just going to have to do is take that applied impulse value, which is going to be 0 to infinity, and we're just going to subtract a value from it, like 5 in this case, which essentially means that it's going to start off at -5 and then add to this value whatever that applied impulse is. So then it's going to go from -5 to infinity in this case. So now our slowest hit will be -5 transpose. So now that's -5, very lower pitched. And then the higher I hit it with more force, the higher pitched that is. And so additional massaging we can do on this value is we can like change the range of it. So if we first offset it, so we start at minus, you can think of this as the min value of our transpose pitch, and then we can multiply that by times 10, which basically means if our velocities go from 0 to 5, it's going to go from 0 to 50 now. So we have to hit it much harder for it to like have more effect to the transpose pitch. But I think, you know, a one-to-one mapping is fine in this case. It sounds pretty good. So our minimum value is -5, and our positive value is will be infinity, so to speak. So we can actually, the harder we hit this, eventually it'll get higher and higher pitched until it reaches the maximum that we can set it to. Now the other thing we're going to see on this transpose pitch value here is that if we keep it using nice round units, we're gonna increase the pitch using on a semitone scale, which is what we want. If we allow it to have integral values like these like non-perfect values, we're gonna be moving not up semitones, but we're gonna be moving, you know, inter semitones, which means we won't have a nice scale, a nice note scale. So what we just have to do is round this, because that applied impulse that comes in, it's, as you can see here, it's a very kind of variant value. It's not an integral value. It's a value that has a lot of decimals to it, and so we just want to remove that. And so to do that, I'm just going to say math.floor, which basically is like take the minimum of that decimal value, round it to the nearest decimal, but rounding down basically of this basically, and we can either do -5 in there or outside. It doesn't really matter. So now our scale will move on those semitones. It will only adjust our pitch here in nice even values. It's going to literally say -5, and then the harder we hit it, -4, -3, -2, -1, and so forth. So we'll have a nice semitone scale for our sound, which is what we want to build an instrument. So I think we're almost about ready here to go ahead, and I'm going to remove this print statement so we don't see those on screen anymore. And I think we have everything we care about in this case. Now we can start making copies of this box here, and then assign different sounds to each one. And so I'm going to go ahead and close this, the code window. And now what we want to do is we want to make some copies of this. And so I'm just going to hold on Alt and hold on Shift so that it keeps it aligned on an axis. And I'm just going to be actually one more thing actually. So I'm going to delete that copy we just made. There's one other thing we're going to do here actually, so we can access this in VR as well. Because what we want to be able to do is in VR, if we point a laser at this box, we can also make it play when we point a laser at it. And so let's go ahead and do that first before we start making copies. So I'm going to select this box again. And now I'm going to push this little button up here. This is the menu button of this object on this root here, on this box entity item. And then I'm going to add interactable, this attribute. And we introduced this to you a few times in prior lessons. But what this effectively does is it adds this additional attribute to this object. And it adds these new functions. And these functions essentially will get called whenever we interact with it. So on a screen, whenever we click it with the mouse, we'll get on press, for instance. Or as we hold down the mouse, we'll get on pressing. And in VR, when we click our laser on it, we're going to get this press function to get called. So basically, what we want to just do is, in this case, I'm going to click on the on press function, and we're back in our code here. Let's just call this on collide function. So basically, we're just going to have it do the same exact thing that happens if something collides with it. So basically, when we point our laser at it and click and point, we'll be able to manifest the sound at that time. So I'm just going to say self::on_collide, which is I call this function on myself. And since this thing wants a value for an impulse, which will then determine what its transpose pitch is, we can just pass in 1 on it, which means essentially it will, actually let's pass in 5. So it does the original, it will essentially, by passing in 5, it's going to take that 5, subtract 5, and it'll have a transpose pitch of 0, which will be the original sound in this case. So every single time we collide, every single time we press on it as well, not just on collision, we'll call this onCollide function. And we can actually show this right now. I'm going to hit play, and I'm just going to click it with the mouse. And so now it gets called either if we hit it or if we click it with the mouse. But of course, the mouse or the VR thing won't have any applied impulse, so we always pass in the same value for that. So it always sounds the same every time we click on it. Okay, I'm going to hit stop, and now we're ready to make copies of this and then assign a different sound to each copy. So I'm just going to hold down Alt, and I'm going to hold down Shift 2 so that it stays aligned on the axis. Because if I don't hold down Shift, this thing is free roaming here, but if I hold down Shift, it stays in the original axis alignment of the original object. So I'm just going to move this out here, and then on this copy, the first thing we want to do is maybe set a different color for it. So let's set it to kind of a bluish kind of color. And on this one, we're going to set on its sound. So I'm going to go and find its sound here. We don't want to use the original sound. We want to use a different sound. So I'm going to go back in here in the browser and right-click Audio and import audio clip from file, and then I'm just going to go and find a different sound. And then this user called Sleep here on Free Sound had some cool like distorted piano sounds. I'm going to load one of those and assign it to this audio clip. So I'm going to replace this sound with this. The underlying sound clip that this thing is using, which is this, I just replaced the underlying sound that our new copy is using to be the one that we just applied to it. So now when we hit that one, we'll get a different sound. So we got the nice semitone scale on that. And so we're just going to keep doing this. I'm going to take this, I'm going to make a copy, hold on Shift, and set this thing's color to something else. And then I'm going to go into its sound, its child sound, and I'm going to replace its audio clip. So the first thing we got to do is import a new audio clip from File. Let's do the this snare reverb, and then I'm going to apply that to this one. So now it has its own sound. And maybe I'll do one more here. Hold on Alt Shift. Copy that over. I'm going to set this thing to a different color. And I'm going to change out its sound here. I'm going to import a new audio clip for this to replace that audio clip. And let's use this Bachu created this this scrape sound. Let's see what this sounds like. Huh. And well, let's do another one. I'm going to create Alt Shift. Set this thing's color to this purple color, and I'm going to import its sound. I'm going to set its audio clip. I'm going to import the audio clip. Let's do this cello sound. Okay, that's pretty cool. And so another trick that you could do is, let's say I didn't like that cello sound, I want to replace it. I could just go in here and click on cello, right click on it, and then update from file. We can go and pick a different sound for it. So that's a quicker way to kind of change out the sounds that are here. Okay, so now what we do is we have our pads that we can now play, either by clicking on them, or in VR we can click on it. And by the way, as we get closer to these, it's going to get louder. If you want to make it so it's louder, even if you're further away, what we can do is select the sounds here. I'm going to just select them all by expanding them out here. I'm going to just click all of them. And the sound, for instance, has this property called an inner radius. And you can think of this inner radius is the radius that if you're inside it, you hear the sound at 100%. So right now, if we're within 1 meter radius, we'll hear it at 100%. But right now, we're actually maybe about 4 or 5 meters away from these sounds. So by increasing this radius, we'll hear the sound at 100% volume, even if we're within 9 meters or 7 or 5 meters. And then it drops off after that. So that controls that property. And so now the sounds will be louder even though we're further away. So now that we have this nice little sound box, we can kind of start to go crazy with this and make lots of copies and do all sorts of things. So I'm going to move these to be a little closer to one another. And let's see if we can kind of play around on this scene to do something interesting. So I'm just going to select them all. I'm going to hold down Alt and Shift and just make a copy of all of them. Actually, let's mix up the order. So instead of doing that, what I'm going to do is let's do maybe this goes here, this one can go here, this one can go here, this one goes here, and the red one can go here. So we have that. Now we have this here. And another thing we could do, and so now I'll just take all this and just make a copy of it, so I don't have to sit there and do it all. So we have like this little dance floor of sounds here, and maybe I'll make one more copy just so we have a nice 5x5 set of sounds here. So another thing we can do here is that's instead of making it so we have to roll this ball on it, which is fun, but instead of doing that, let's create an emitter here, a node emitter. And if I create this node emitter, I can kind of create, and I'm just going to point it toward our sphere, our environment. And so it's not going to hit it. Now the spheres that are hitting it are a little bit too, they don't have enough mass to trigger the on-collision event. So what we're going to do is just crank up the mass of those. So I'm going to click the node emitter, and then I'm going to find the sphere property that it's currently emitting. I'm going to click on that on its rigid body. I'm just going to crank up its mass. And another thing we'll do on this is we'll make them bouncy. They bounce a little bit. And actually, since there is no bounciness right now on these mesh entities, we're going to have to make the boxes to be a little bouncy too. So I'm just going to select them all, go to the rigid body, and I'm going to set their bounciness to be like 0.3 is fine. So now we'll get a nice bounciness. Maybe this box here a little bit better. So another thing we could do is we can add some variance to the velocity as they come out, because the velocity determines the pitch of our instrument. Because right now it's always emitting them at the same velocity, we're always kind of getting the same pitch on that initial instrument. So let's add some variance to the velocity of this node emitter, so that every single time it hits them, it does something a slightly different pitch. So I'm just going to select the node emitter, and I'm going to go to the initial velocity of that emitter, and I'm going to hit this little button to the right of it, and I'm going to add a number normal distribution sampling attribute. So what this is basically going to do, it's going to use a distribution that we can control using the standard deviation parameter that basically says this is our mean, this is the average value that's normally going to strike. It's going to be an initial velocity of 10, or it's going to be the velocity that they're coming out. But it's going to basically, you can think of that being sandwiched plus and minus this value. And it will pick values within that distribution, basically. So the bigger I make this, the bigger the range of values that it's going to pick. So it's going to basically, you can think of it as choosing between 6 and 14. In this case, it would be the distribution range, the overall distribution range. So some come out fast, some come out slow. And I'm going to make a copy of this emitter. Oops. Each column here, this thing's slightly different. This is not a very good song here, but a little loud and probably a little annoying here. So one of the things we can do is we can keep building up. We can keep taking this structure here. More instruments, more sounds would be more fun, but we can have them. Let's actually reduce the number of. Let me just go back to so that's one thing you could do. You could create like a dance floor, kind of a dance pad thing. Another thing we could do is, for instance, we can create a multi-sided space. So actually, let me just go back and do this again. We lost our original white one here. Let's just do that. It's the easiest way to do this. So another thing we could do, for instance, is build a 6-sided cube, and then we can send some things crazily bouncing inside it. So I'm just going to take all of these. I'm actually going to group these together, Control E to group them so that moves as one unit, and then I'm just going to make a copy of this. I'm going to rotate it holding on Control Shift. I'm going to stick this on this side. Control Shift, I'm going to create it on this side. And for instance, what would this do if we were to send a sphere crazily bouncing in here? So I'm going to just bounce this on this side here. Oops, totally missed. How embarrassing. I'm going to move this a little bit back. Maybe we'll have these things come off a little bit more velocity. So I'm going to crank up the mean of our physics initial velocity. In some cases, it might be coming right through it because it's a little bit, because these are so thin, these boxes. If the box is a little bit accelerated a little bit too fast, the sphere it can just poke right through. So that's kind of interesting. And so there's lots of things you can kind of play around with in this case. And so the other thing is in VR, because these things, we can also click on them directly. If we have our, I'm just going to erase this. If we create a VR rig here, our VR rig preset, I'm just going to plop this right in the center of this dance floor thingy here. Now with our laser, we can kind of activate them is one way to make this work. So I'm going to go into VR mode. And now I'm going to use my hand here. First thing I got to do is make sure Oculus is not putting me in their little world here, which they like to do. Okay. Now I'm going to immerse myself. And now anything I click on, laser does this. So another thing we can do is, instead of doing that, we can make it so that we can shoot using our hand, we can shoot like a ball out. So there's some travel time, and so instead of being the emitter in this case, we're going to make our hand the emitter, and then when we pull a button, when we push a button on our VR hand, it will shoot out a ball. So let's set that up. So I'm going to pull this for now. I'm going to move this away here. I'm going to actually grab the VR rig. I'm going to pull it out here so we can work with it. And I'm going to exit VR mode so that it kind of reasserts our default positions here, so they're a little easier to work with. So that what I want to do basically is, whenever I push a button up, maybe on my right hand, whenever I push the index trigger on my right hand, I basically want it to to emit a node. And so to do that, what I'm going to do is I'm going to create, for now, we're going to set an interaction on this index trigger, and we're going to then replace. It's just an easy way to kind of to have it place some of the code, and then we're just going to subtract it out. So I'm going to click on the glow interaction. I'm just going to click on the index trigger. So by default now, what's going to happen every time I pull the index trigger, it's going to make my finger glow, which is a little weird. And actually, I can demo that to you. And I'm actually going to also delete the laser pointer. We don't want the laser pointer on our right hand anymore. So I'm going to just take it, and I'm just going to erase that laser pointer, because we want the balls to emit from our hand, and I don't want to see that laser at the same time. So right now, I just added the interaction directly to my hand, and I can show you what happens when we hit play here. It's not causing it to glow, so let's not worry about that for a second. Okay, but what we actually care about is, I need to remember why that isn't the case here, but what we actually care about is changing the code that happens when we press it. And so what we want to have it do is, when we press it, we want it to emit a ball, basically, that comes out of our hand. And so to do that, I just deleted the code that lives in that glow. In fact, we can rename this to emit node. And I'm going to create a node emitter. I'm going to exit VR mode to assert that. I'm going to create a node emitter. This is the thing that's going to emit our spheres. And then I'm going to set this as a child of the index of the right hand. So now I'm going to change its transform. I'm going to zero out its transforms so that it lives exactly on the parent at 0, 0, 0 on our parent node, which in this case is our hand. I'm going to rotate this 90 degrees so that it faces the direction of the hand. And I'm also going to bias it just a little bit in front, so it's in front of our hand. Okay, so now if we hit play, it'll just kind of emit, but we want to make it so that we push a button to make that happen. So to do that, I'm going to go into the node emitter. And the first thing we want to do is remove that constant pulse, which is causing them to kind of constantly come out. I'm going to hit none on that, And then we just need to write some script to kind of emit a node every single time we call press. So in our emit node code that we cleared out before, I'm just going to just drag and drop this node emitter into it. And then we're just going to say emit node. So now every single time we press the button, it's going to call emit node. It will emit a node here. We go back into VR mode. And there we go. And so the other thing we need to do is crank up the mass of these nodes that are emitted so that they actually influence the space. So I'm going to go into the sphere. This is the sphere sample of our node emitter, and I'm just going to crank up the mass here a little bit. So now, I'm going to hit stop. I'm going to move the VR rig back to the center of this world here, this dance floor-y thing. And now when I go into VR, I'm going to immerse myself. And actually, I'm going to set this up to be monoscopic here so you can see this better. When I immerse myself and pull the trigger, we can now, I can't quite make it way up there, so we could play around with velocity. This is the issue. Okay, so we have a sense of how to create this instrument. We can import a lot more things into this. We can do a lot more kind of, we can import other sounds. We could potentially do these things on hover. There are a lot of other things we can potentially do instead of having them play on collision. Again, I can show you that here. I'm just going to delete out these old ones here. Oh, no, I just deleted the original objects. One sec. So I'm going to go back into this group here. And I'm just going to open. I'm going to destroy this group. Shift delete it, and now we put all these objects back into the main space here. I'm going to delete all of these. Get us back to the original samples. Will that be good? Okay. And I deleted my VR rig. Oh well. Actually, no, that's not good. Let's bring the VR rig back. So another thing we could do is do these on hover instead. So instead of playing on, back to this original sound, let's say we wanted to have this play on hover instead, we could do on hover on, and when we hover on our mouse, it will play the sound. So instead of on press, like we did before, on hover, now when I move the mouse over, or the laser, it will also play it. So this is just another way we can play the sound. That's another example. So that's about it for this example. I will share this online. Actually, let me. I may have lost those, but let me recreate. Actually, you know what? I'll leave it simple like this so that you can kind of go in and make changes to this yourself from this original starting point. And I'm going to go ahead and share this onto Steam. I'm going to make this educational sandbox public, and I'm going to set the title to be a musical collision instrument. And I'm going to set this to be 30 days of symmetry. And here's a good time to give attribution. So this title card is where we can kind of give a long description of this, and it will appear here. So the title card is, this is an experience for this is an example of creating a collision-based instrument. And we can give attributions to the artists. In this case, the attributions we'd want to give would be these free sound artists. So I can go and they're actually all the audio samples have them as the name. So if we go into here, I can set batch coup attributions. This is always good to do this so that you respect the original artist. It's always good to do this. Sound scrape, so scrape by batch coup on freesound.org. I'm just going to copy and paste this for each of the sounds. So sleep did one, Tim Khan did one, noise collector did 2 of them. And this guy did power. Just going to copy and paste from here. This guy did this one. Cello is this guy. Con. And sleep did P5. Okay, so now we have attributions for those, and we're ready to share this. So I'm going to go ahead and reshare this onto Steam. And then once you've shared it, you can click on this share button here and take this link and paste this wherever. So I'm going to go ahead and paste this into the Discord channel so you can kind of see it. And I'm going to have to exit VR mode to do that. And 30 days of symmetry. Here's 2 days lesson. And there it is. You can subscribe to it and download it and modify this example. And actually, I'm going to move the VR rig to be closer here. I'm going to reshare this so it re-updates it. Okay, so there we go. So any other questions, hit us in Discord. And by the way, if you're viewing this outside the Discord channel, you can always join it by clicking on the Learn menu and join the Simmetri Discord server, and it'll get you into our community there. And so hope to see you guys next time. Hope you enjoyed this demo.